All right, this is the Prequiz 9-1, which has to do with force equilibrium. All right, so we've got these two forces. We've got this guy here, which is 31 degrees, and it's 23 newtons. And then this guy is 42 degrees and 17 newtons. And then there's going to be some equilibrant on this thing that is going to, I don't know, it's going to be somewhere. It's like almost straight down, right? It's going to be negative the sum of those, right? So I'm going to call this guy B, this guy A, right? And the magnitude of A is 17 newtons. And the trig angle is, going to be what? 90 minus 42, which is 48 degrees, is that right? And then X component, Y component. Okay, and then this guy is 23. B is 23 newtons, and it's 90 plus 31, so 121. Do I have the trig angles right?
I believe so.
Okay.
If you want to, just check the circuit worksheet.
Oh, you got it. Okay, good enough.
Anyways, a little question.
Yeah.
When it comes to XY, do you actually want us to put like the lateral and the horizontal?
Yeah, just set up your equations.
Well, I already did, but what I'm asking is, do you want like how much tension is in C or D, or how much force is on X and Y?
X and Y, I want you to set up an X equilibrium and a Y equilibrium equation, and then just solve it with matrices.
Okay.
I'll do it in here in a sec.
I'm sorry, that's just sort of like, here's the answer. Now do it again in a weird way.
Yeah. Cos 48. Okay, so I'm going 17 cos 48, and I get 11.375. And I'm going to go 17 sine 48, 12.633. Okay, and then 23 cos 121. So minus 11.846. And then 23 sine 121, 19.715. And then I'm carrying extra digits so that when I add them all together and do everything, I won't be too far off. So 11.375 minus 11.846. So I'm going this guy plus this guy, which is of course subtracting, right? And I get negative. And then this guy is 12 point plus 32.348. Right, so the equilibrium is positive 0.471, negative 32.348. Right, so pretty much it is straight down, but a little bit to the right. So there's the axis, here's the equilibrium. Right, and it's actually going to be pretty long. Right. This side here is 32.348. This side here is 0.471. So the magnitude is the square root of right. That's 32.351. And these are newtons. And then this angle here is tan minus 1 of the opposite over the adjacent point. So inverse tan of I'm getting like, oh my God, is that 0.8 degrees? What's the answer? Oh, 270.8. Okay, so that's the angle right there. Just to the right of straight down is 270, right? So the trig angle would be 270 plus 0.8. So then it equals 270. And 32.4 is our magnitude. I need a different color. Huh? No, I need another color.
And then this is the mass times gravity. And the answer right here is
Okay, let me try let's do the second part here. Find the tension C and D. So this angle here is 56 degrees. This one here is 34 degrees. Right? And I'm pretty sure this is going to be less of a force. Right, so this guy, they've got a force that way, a force that way. Making that this guy's got. Like that. And then the downward force is, of course, the weight of 35 kilograms. So there's a 35 kilogram mass here, so 35. 343.35. Right, this is C, this is D. This is D sine. This is D cos. This is C cos 34. So you find these sides, right? This is C sine 34. And then our equations in the x direction look like this. Minus C cos 34 plus D cos 56 equals 0, right? And then in the y direction, we've got these guys, right? So C sine 34 plus D sine 56. That equals this guy down, 343.35. Right? And now we can set up a matrix with this. We can represent this with this matrix. Right, and then that is times C and D. Right, so here are the coefficients of C and D, and then that equals right. And if you set this up as matrix A, and this one is matrix B, then this matrix here, the matrix equals A inverse B. I'm going to switch